Hi everyone, and welcome to this video where I'll provide a technical overview of Microsoft Fabric. I'll break down the service by its main components, its architecture, its various experiences, and give a demonstration so you can get familiar with the platform. The objective of this video is to ensure that you understand what Microsoft Fabric is, the challenges it addresses, and all of the various experiences that the platform consists of. By Microsoft's own definition, Microsoft Fabric is an end-to-end analytics and data platform designed for enterprises that require a unified solution. It encompasses data movement, processing, ingestion, transformation, real-time event routing, and report building. I appreciate that definition is quite a mouthful, and I'll spend some time explaining what that means in a more practical context. To do that, first let's consider what is the problem that Microsoft Fabric is trying to solve. Prior to Fabric, organizations would use different data tools and services for their data ingestion, orchestration, engineering, real-time, and data science workloads. If I was to represent one possible solution architecture for this using Azure Cloud Services, then it would look like this. You can use Azure Data Factory or Synapse Analytics pipelines to ingest the data and store it on Azure Data Lake Gen 2 storage. You can process this data using Spark pools, SQL pools, or dedicated SQL pools in a Synapse Analytics environment. You can then leverage Power BI to generate insights. In this current architecture, we're leveraging many different services. While all of these are Azure services, the implementations can still get complex. In reality, organizations will be using services from multiple vendors, which can get even more difficult. You'll also have a lot of other services for additional workflows such as real-time streaming, machine learning, data governance, monitoring, and more. You have to ensure integration between all of these services, monitor the services, and manage the expenditure. And furthermore, since you're using different services, there's a risk of creating data silos. You can end up replicating the data, as the same data may be stored in multiple different places. Monitoring upstream and downstream data can also be challenging. Microsoft Fabric addresses these challenges by combining all of these different services into a single platform. It's essentially Azure Data Factory, Azure Synapse Analytics, Real-Time Analytics, Data Science, and Power BI in a single unified platform. So what it does is it offers a seamlessly integrated, user-friendly platform that simplifies your analytics requirements. Fabric operates on a software as a service or SaaS model. At the time of recording, there are 8 main components in Microsoft Fabric. Data Factory is a data integration experience to ingest, prepare, and transform data from different data sources. At the time of recording, it has over 200 connectors to different data services, both on-prem and on the cloud. Synapse Data Engineering allows you to create data lakehouses and use Spark to store, process, and analyze vast amounts of data. Real-time intelligence is an end-to-end solution to query and analyze large volumes of data in real time. Synapse Data Science enables you to build, deploy, and operationalize machine learning models. Synapse Data Warehouse provides a cloud data warehouse built on top of a distributed processing engine, providing industry-leading performance and scale. It decouples storage and computing so you can scale both components independently. Power BI, which is Microsoft's data visualization and business intelligence service, and you also have newer additions such as Data Activator, which monitors data in Power BI reports and event streams items. For when the data hits certain thresholds or matches a pattern, it sends alerts and notifications. And finally, you have Industry Solutions, which provides industry-specific data solutions. These workflows are quite diverse and bring together personas from a range of different skill sets. Microsoft Fabric enables a single platform where data analysts who want to analyze reports on Power BI or query data from an SQL warehouse will use the same platform as a data engineer who wants to create a data pipeline from one storage location to another, or where a data science wants to build and deploy a machine learning model. All of these different personas will use Microsoft Fabric. They'll work and collaborate with each other and leverage the same data sources stored in the same place while using different workflows. That is what makes Microsoft Fabric a game changer. If you're familiar with the Power BI service, then you can think of Microsoft Fabric as an extension or major enhancement of this service to include all of the additional workflows. Just like with the Power BI service, we still have many of the same concepts such as capacities. A capacity in Fabric is the compute engine. You pay for a single capacity that serves as the dedicated compute power and resources for running all of your workloads and experiments. The size of the capacity, which is determined by SKUs or stock keeping units, determines the amount of computation power available. When you sign up for a free 60-day trial with Microsoft Fabric, you get an F64 capacity, which would normally cost about 10k a month in the UK South region. The lowest SKU, which is an F2 capacity, costs around $300 a month, and the largest capacity is currently over 300k per month. With Microsoft Fabric and the pricing model, you have transparency over how much you're going to pay. If you use a combination of services from multiple different vendors, then you'll have to monitor consumption and usage across all of these services to understand the pricing. But in Fabric, it's a much simpler pricing model, as you just pay for the capacities and OneLake storage. And that brings me on to OneLake. OneLake is the foundation of Microsoft Fabric. All of the data across all of the different workspaces and workflows is stored in OneLake. It's a unified location to store all of your organization data. By storing all of the data in the same place as where the workloads operate, OneLake eliminates data silos, which individual developers often create when they provision and configure their own isolated storage accounts. OneLake is built on top of Azure Data Lake Storage Gen 2. For those of you unfamiliar with that, it's a cloud storage service on Azure. And a really cool feature of OneLake is shortcuts. Shortcuts allow you to point to data outside of Fabric, so you don't actually need to copy data into Fabric, avoiding data duplication. The default file format of OneLake is Delta Parquet, which is an industry-leading format that provides numerous benefits such as data versioning, schema enforcement, time travel capabilities, and ACID compliance. It stores data in columnar format, and it's extremely efficient. And because the data in OneLake is the same Delta Parquet format, it can be used across all of the different workloads seamlessly, using the same data across multiple engines. Furthermore, OneLake, combined with the integration of the different experiences, enables easier governance, access control, and monitoring. So I hope you're beginning to understand the overall architecture and how Microsoft Fabric is able to unify different workflows to provide a platform for multiple personas, ranging from data analysts to data engineers to data scientists. Now that I've covered the theory around Microsoft Fabric, let me give you a demonstration. I appreciate that this will be a first look for many of you, since the majority of you will have little to no prior experience of the platform. The purpose of this demonstration is to give you a first look and get you excited about the service by showing you how the various workflows can be leveraged and what they can do. I'm currently in the Microsoft Fabric landing page. From here you can see all of the different workflows or experiences as they're also known as. If you click into any of these experiences, then you'll be taken into Microsoft Fabric. So let me click into this Synapse Data Warehouse experience. If you're familiar with the Power BI service, then this will look very familiar to you. All of your objects across the different experiences are organized into workspaces. So I've got a workspace called Fabric Demo. When I click into it, you can see all of the objects in this workspace. So as you can see, I've got a lakehouse, I've got a notebook, so these are part of the data engineering experiences. I've got a sample pipeline, which is a part of the data factory experience. I've got a sample reflex, which is part of the data activator experience. I've also got a sample warehouse, which is part of the data warehouse experience. So I hope you're starting to see how Fabric really is a unified platform. You can manage access to your workspaces, and you can also manage the settings as well. So under workspace settings, under licenses, you can see that this workspace is assigned to this trial capacity. You can purchase multiple capacities and assign a capacity to a workspace, and that will be what powers that workspace. Okay, so let me navigate back to the data warehouse experience. So I'll click on this bottom corner and then select data warehouse. This takes you to a new page. Here are the objects I can create in this experience. So I've got a data warehouse, which I can create, and I've also got data pipelines and data flow Gen 2. These are technically data factory experience items, but they're here because they can be used to move data into and out of a warehouse. You'll also notice there are some mirroring capabilities as well. So if we have data in an external location, so for example, an Azure SQL database or a Snowflake data warehouse or Cosmos DB, then mirroring allows you to replicate the data into your OneLake and hence Microsoft Fabric. It's a low-cost, low-latency, turnkey solution that allows you to do all of this with minimal fuss. So let's explore data warehouses in Microsoft Fabric. specifically one that I've already provisioned. So if I go to my Fabric demo workspace, you'll notice there is a warehouse here called Sample Warehouse. So let me click into that. This sample warehouse can be queried using TSQL. You can create a query here. So notice I've got schemas and I've got all of my tables here and I've got some views. So this is just sample data. So if I want to perform any queries against this table, I can just create a new SQL query like so. So I can just select star from trip and then run this query. And here is the result. So this sample data warehouse can be queried using TSQL, so you can run queries against tables and views, and you can also create stored procedures. There's also something else I'd like to show you, which is this new visual query. So using visual queries, you can actually construct an SQL query using a drag and drop interface. So let me open a visual query. So I'll do something a little bit more complicated now. I will join this trip table, which has a geography ID key, to this weather table, which also has a corresponding geography ID key, so that I can merge the columns together. So let me go back to my visual query. So all of your queries are down here. So I'll just open that visual query. I will drag this trip table in the query. And then I will drag this weather table in the query as well. So notice the trip table has been populated here. And now I will drag this weather table here. So now this is the weather table. So that's being populated. So if I click on this plus, I can perform a merge queries operation. This is the left table, which is the trip table. I want to select this drop-off geography ID, and I want to join it on this right weather table here. So this is now doing a left outer join, and I'll press OK. So now we have the resulting data set down here, and I can expand the columns from this right table that I would like. So let me select all and click OK. So now we have the resulting table, and you can also view the SQL that has been generated as part of this visual query. So here is the SQL, as you can see. So all of your tables and views can be added to a semantic model. This semantic model is a data model that's ready for consumption by Power BI. So on the reporting tab, notice we can manage the default semantic model. Currently, that consists of all of these tables and views in this DBO schema. So we can use these tables to create a report in Power BI. So naturally, let's move on to the Power BI experience. So in the bottom corner, let me select Power BI. So here we can create Power BI reports. So we can create visual reports to present insights. So when I click on New Report, I can select data in the form of Excel or CSV, or I can pick a published semantic model. Let me do that. So for this sample warehouse, I can select the semantic model. So let me just auto create a report. So this will just automatically create a Power BI report. So as you can see, it's created some quick visuals based on the tables available in this semantic model. And here they are along the right. Great. So now let's move on to the data engineering experience. So in the bottom corner, I will click Data Engineering. So here we can create lakehouses and notebooks, among other things. So let me go to one of my sample lakehouses in this Fabric demo workspace. So I will open this sample lakehouse 63. So in this lakehouse, I've got tables and I can also store files in that lakehouse. The tables are by default Delta format tables. With lakehouses, the Apache Spark framework is leveraged. Apache Spark is optimized for big data workloads. You can process and query data in tables and files using notebooks. Notebooks allow you to write code in cells. So you can code in Python, Scala, SQL, or R. So let me open an existing notebook. So here is a notebook that I have. So I'll open that. So this notebook is coded in Python. As you can see, that is the language that's selected, but you can also select these different languages as well. You attach a specific lakehouse to a notebook, and then you can add markdown text, or you can add code cells as well. So I can run this code cell. This is using PySpark to read data from this files location in our lakehouse and display it as a data frame. So if I run that, this will be the result. So I'll just run it again, so it will just reprocess that. So here's the result. The data in your lakehouse, so if I go back to my lakehouse here, is also available to be queried using an SQL endpoint. This SQL endpoint can be accessed by clicking this dropdown and selecting SQL Analytics Endpoint. So the same data that's available in your lakehouse is available here. So you'll notice the tables are the same. This is meant to look and feel like a data warehouse. So this is suitable for people with an SQL skill set to analyze the data in this lakehouse. And you'll notice it looks exactly like the data warehouse that I talked you through earlier. So you can create an SQL query, a visual query, and in the reporting tab, you can also manage the default semantic model. So all of your tables and views in your lakehouse can be added to a semantic model, which can then also be consumed by Power BI. Great. So now let's move on to the data factory experience. So here you can create data pipelines and data flow Gen 2 processes. A pipeline can move data from one location to another. So I've got a sample pipeline in my Fabric demo workspace. Here it is. So this pipeline has just been configured with a copy data activity. This copy data activity is copying data from this source location, which has been provided using a connection, into this destination. So this destination is just my lakehouse in Fabric in the files location. So this is copying data from a source to a destination. So this data pipeline activity can copy data to and from a variety of different data sources and sinks. A data flow Gen 2 activity is a bit like Power Query, if you're familiar with that. While the copy data activity is more of a data movement activity, data flow Gen 2 can perform data cleansing and transformation too. Okay, so let's move on to the real-time intelligence experience now. So let me click on the drop-down and real-time intelligence. Here you can create event streams, event houses, KQL databases, and KQL query sets, in addition to real-time dashboards. The event stream feature lets you bring in real-time events into Fabric, transform them, and then route them to various destinations without writing any code. So this is a no-code service. Event houses are analytics engines used to process data that's in motion. Data can then be queried in KQL, which stands for Kusto Query Language, or it can also be queried using TSQL in this KQL query set. So let me show you a sample of a real-time data flow. So in my Fabric demo workspace, I have got an event house here that is linked to this KQL database. So let me click on this weather sample event house. So you'll notice you get an overview of the system itself, and then there are associated databases with this event house. So here's a database. If I click into this database, it has got an associated weather table. This is a real-time table. So if I click into the three dots, I can actually query this table. So if I click on show any 100 records, it will generate some KQL code for me, and it will run that code. So it's just run that code. So this take 100 just means it will take any 100 records and display them. So it is doing it from this table. So this is KQL syntax. Great. So now let's look at the data science experience. Here you can use Fabric for the end-to-end data science process. You use notebooks, which are the same notebooks as in the data engineering experience, for your data exploration and preparation. You can use these notebooks to train your machine learning models, log your experiments, and register the models as well. Whenever you train a model in a notebook that you want to track, you can create an experiment in Microsoft Fabric. An experiment consists of multiple runs of the model. Each run represents a task that you executed in a notebook. So this is like training your machine learning model. And after you train your machine learning model, you can register it and use it on new data sets to generate predictions or insights. So let's move on to Data Activator. Data Activator is a no-code experience in Microsoft Fabric for automatically taking actions when patterns or conditions are detected in changing data. It can monitor data in Power BI reports and event streams items. A reflex holds all the information necessary to connect to data, monitor for conditions, and act accordingly. You'll typically create a reflex for each business process or area that you're monitoring. So I've got a sample reflex in my workspace. So here it is. So if I click into it, you can see here are the events that are being monitored by this reflex. And then here are the triggers. So here's a trigger, if the medicine package is too warm. So I have configured this. If the temperature becomes greater than 50 degrees, then it will activate the trigger. And you can see all of the trigger activations here. And the act is to send an email to this recipient with this subject and this headline. Okay, so now finally, we have industry solutions. These are pre-built data solutions for specific industry use cases. We've got sustainability solutions, retail solutions, and healthcare solutions, and I'd expect more to be added over time. These data solutions address the unique challenges faced by different industries. Okay, great. So that was a technical overview of Microsoft Fabric. I hope it's given you a good insight of what Microsoft Fabric is trying to do and how different personas can leverage the different experiences. I appreciate that there's a lot covered in this technical overview, and it's difficult to process all of this information right away. I do plan to create more content in each experience separately, so please stay tuned for that. I'm also in the process of creating a full-length Microsoft Fabric course. Once that's ready, I'll share a link in the video description. If you enjoyed this video, then please show some support by liking and subscribing to my channel so I can continue to grow and produce more content.